Okay, yesterday we finished off class, I think, with number 3, yes? Okay, so what I would like you guys to do is try number 2. Right? Scale and direction are kind of important on that one because there's a little bit of backtracking. But let's say write it down so you have this example in your notes, and then in the next couple of minutes, try and get the diagram drawn, and then I'll put the diagram up, you can check, and then move on to the other steps after that. Okay? Okay guys, let's have a look at this diagram here. All right, so our first vector is 15 meters at 15 degrees north of east. So my reference direction is due east. So I'm just going to draw a dotted line due east as my reference, and then I'm going to go 15 degrees north of that, so that would be above it. Okay, 15 degrees isn't a very big angle. Okay, and this is also 15 meters long. This would be its x component, and this would be its y component. All right, our second vector is 13 meters long, so just a little bit shorter, but it's 5 degrees west of north. So my reference direction is north. So I'm going to draw a dotted line that goes north, and I'm going to go 5 degrees west of that, so an even thinner triangle. Okay, that would be 5 degrees west of north. This is where scale is important, right? If you make that really big, your mathematical answers are not going to match your picture, right? And that means then that my overall resultant is that blue line right there. That's what your diagram should look like for that one. Okay, as I said, guys, it's the diagrams that people struggle the most with and need the most practice on. That's why we do so many of these. I know you guys can do the trade. I'm not worried about that part. Okay, I'll give you a few more minutes on that. What's the next step now that I've got all the diagram drawn and the x's and y's identified? Now I need to okay, well, I'll let you get figured out. Okay, guys, let's kind of take a walk through this question here. So the next step is that I've identified my x's and y's. Now I need to calculate all my x's and y's. That's the heavy lifting of the question, is doing all the trigonometry. So red x is adjacent to my 15-degree angle. So what trig function do I use for that one? Which one? Cos, yeah, it's adjacent and I have the hypotenuse. So I'm going to use cos, right? So we'll go cos of 15 times 15. All right, so cos of 15 times 15 is going to give us 14.49 meters, and that's east. All right, so we've got that, which means y is the opposite side, so I would use sine for that one. Sine of 15 times 15. We're looking at 3.88. meters. That's north. And then for our green triangle, x is opposite this time. Okay, it's opposite the 5-degree angle, so for that one we'll use the sine of 5 times the hypotenuse, 13. So that's going to be a pretty small side. Okay, so 1.13 meters. That one's west. And then for y, it's adjacent. So cos of 5 times 13. All right, so that side is 12.95 meters. And that is also north. Okay, so now I've got all the x and y components. Now I can build the triangle for my resultant. Okay, blue x is going to be the sum of red x and green x, with of course green x being negative because it's west, or you could just subtract it, right? And blue y is going to be the sum of both red y and green y. They're both north, so I can just add those two numbers. Okay, so if we're looking at those, okay, blue X is going to be 14.49 plus negative 1.13. And of course, we're going to use all of the decimals that we have. I'm just going to subtract in the calculator. So 13.36 meters east. And for Y, we are 12.95 plus our 3.88 there. And that's going to be 16.83 meters north. All right, now that I've got those, how do I get D? Use Pythagorean theorem, right? I've got the two sides, so x squared plus y squared. Okay, so we'll have our 13.36 squared plus our 16.83 squared, okay, and that'll give us our magnitude for our displacement. And of course, we're going to use all of our decimals there. Whoops, I got to put a plus in between them. Okay, so that's going to be 21.48 meters. Okay, and then I've got to calculate theta. Now, if you drew the triangle this way, that's totally fine. You're just going to get the opposite angle of me. So I'm going to go 10 to the minus 1 of x. That's opposite for me, 13.36 over 16.83. All right, so we're looking at 38 degrees there. And the way I drew that, it's going to be east of north. Okay, only thing left now is the correct number of significant digits, which on this question is 1. The 5 degrees only has one significant digit. Just so you know, I hate that. Okay? I think that's a total cop-out to have one significant digit. So in a question I make up, it'll never have one significant digit. Okay? But in this question, that's what we got. They actually do it wrong here. For whatever reason, they've got 2 significant digits on their answers here. It's part of the reason we don't use this textbook. Okay, there's some good stuff, but they screw up a lot. When we first ordered them, we were going through it, Mr. Dickey and myself, and we're like, that's wrong, that's wrong, that's wrong. So we sent it back, and we're like, this is wrong. So they sent us a corrections booklet. It was, I kid you not, this thick. Okay, for a textbook that was that thick. It was like 1/4 of the book. And then they're like, yeah, and the corrections booklet costs $20 each. And we're like, what now? So you messed up and now I'm supposed to pay for the corrections? I don't think so. Yeah. It's not good marketing there. Okay, so one significant digit. We should have, as our final answer, 2 times 10 to the 1 at, I would say 4 times 10 to the 1 degrees east of north. So, yeah. That's why we don't like having one significant digit. Those are pretty dumb numbers. Okay? All right, how are we feeling about that? Now, that diagram scale was important, as it is on any diagram, but we're going to do some where they're going to like backtrack almost completely, and scale's going to be really important. All right, and that's what we're going to kind of practice over the next few days, is do a bunch of these so you really get practiced up at drawing the diagrams. Again, I'm not worried about drilling you on your trig. Okay, that part I'm not worried about. The diagrams are super important. Okay, let's have you try this one. It does have one extra step at the end because you are asked to calculate the velocity. You are given displacement vectors here and a time at the end. Okay, so just do the displacement part and then worry about the v equals d over t at the end. Okay, so for our diagram here, guys, first the combine moves 950 meters at 30 degrees north of west. Okay, so I'm going to start up here. I'm going to draw a reference line that's west, and I'm going to go 30 degrees north of that. Okay, so there's my 950 meter vector. Okay, and then I've got 385 meters at 45 degrees south of east. Okay, so I've got to draw a reference line that's east. Okay, and I know that this line is going to be less than half as long as the 950. But does that get dangerously close to the x component of my first vector? Like, sometimes it's hard to guess whether I should stop short of this or go past it on my diagram. Okay, that's where scale is really important. And it might end up that when you do the math, you look back at your diagram and go, okay, I wasn't sure about that line and my math says I drew it wrong. Okay, and that's okay. You can always go back and fix it after. All right. For me, I'm pretty sure that at a 45-degree angle, this is not going to get lower than here. Okay, so I'm going to go at a 45-degree angle for 385 meters. Okay, I'm going to say that's where that ends up. Okay, that's 45 degrees south of east, 385 meters. I think that's about right. I might have even drawn that line a little bit long. Okay. In fact, I'm pretty sure I did draw that a little bit long. I'm going to back it off just a bit. I think it's just a little bit too. Okay, so that is going to put my resultants here. Is this a really busy looking diagram? Sometimes they get that way. If there's like backtracking, there's always going to be a busy looking diagram. All right, so you could separate the triangles if you wanted to, but then it doesn't give you the big picture. Okay, so I would say, well, let's go with that. Our green line is our resultant. Okay, you can move on to your next steps there. Okay, let's have a look at this one here, guys, because as I said, this is probably one of the trickier diagrams that you'll get, just because there's so much backtracking and guessing as to whether it gets, how far it gets. Okay, so let's do the blue triangles first, or the blue triangle first here. X is adjacent to the 30-degree angle, so we will have cos of 30 times 950 meters. All right, so we're looking at 822.72 meters west. And then for y, it's the opposite side, so sine of 30 times 950 should be 475 meters north. Okay, and then for the red one, x is again adjacent, but does it matter? Or did I save you a little work by using a 45-degree angle? Save you a little work, right? If you actually punched in cos of 45 and sine of 45, then you probably went, okay, because you didn't have to do each one. The sides are equal and the angle is 45 degrees. Okay, so we'll just put in here cos of 45 degrees, okay, times 385, just to get the number, and then we'll just use it again on the other side there. So 385. All right, so 272.24. meters, and for x, that is east. Okay, and then for y, it's 272.26 meters south. All right, now at this point, this is where I would check. Okay, I got that my y component for the blue triangle was 475, and for red y, so how far down it comes, 272. So that confirms that I did in fact draw that triangle correctly. Okay, always good to double check. Now we're to the point where we can calculate the resultants x and y components here. Okay, so resultants x, we're going to take 822.72, which is to the west, and we're going to subtract the 272.26 because it's east, and get our resultant there. So 822 minus that number. All right, so we're looking at 550.49 meters west, so 550. And then for y, we're going to take our 475 and subtract 272.26. Okay, so 202.76 meters north, because I did end up north of where I started. All right, at this point now we can do our Pythagorean theorem to get d. All right, so that'll be the 550 squared, obviously with all the decimals, plus 220 squared, again with all the decimals. All right, so that's going to be 586.64 meters. Whoops, I put that where theta is supposed to go. Okay, and then for theta, we're going to be 10 to the minus 1 of opposite, which was y, so 202 divided by 550. That'll get us our angle. All right, 20.22 degrees. And for me, that's north of west. Okay, but if you got the 79.88, it'll be west of north. Okay, so now I've got those, and now what I need to do is the last step. That calculates the displacement. What does the question want? Wants velocity, right? If the whole trip takes 540 seconds, what is the average velocity? How do we calculate velocity? Yeah, displacement divided by time. I just did all that work to get the top of that equation. Right, now I can just plug in my numbers there. So that'll be 586.64 with all the decimals and of course the vector, okay, divided by 540 seconds, right? Okay, so I take this number here, 586, whoop, too far, and divide it by 540 seconds. All right, so my final answer is only going to have two significant digits. So that'll be 1.1 meters per second at 20 degrees north of west. Okay, are we starting to get the pattern? Okay. I mean, every single one we've done. We drew the picture, we identified the x's and y's, we calculated the x's and y's, we put them together to get the resultants x and y. We did Pythagoras, we did trig. It's always going to be the same steps. All right, let's see if we can get one more done here. Let's go with C. Okay, this is in the digital workbook, or the workbook if you printed it, so if you have it, that's number 3C from the vector page. All right, well, let's try C. let's have a look at the diagram here. So we got 8 meters east. Okay, so we just got a horizontal line pointing due east. And then we have 6 meters at 35 degrees north of east. So I'm going to draw a reference line that's due east. I'm going to go 35 degrees north of that for 6 meters. And I think my scale is reasonable here. So this will be X and this will be Y. Okay, and that'll make my resultant. Okay. Look like that. Okay. You could also draw the triangle this way. It makes no difference, but you can see why one would be 75 and one would be 15 degrees, okay, when you draw it the other way. Okay. All right, give you a little bit more time on that one. We might have to finish, we will have to finish that one on Tuesday morning, right? But work on it as much as you can here before the bell goes.